The Earth receives about 90 petajoules of energy from the Sun every second. That's a lot, enough to satisfy all human energy needs thousands of times over. However, the Earth also radiates an equal amount of energy back into space as heat. An almost equal amount anyway. The Earth is gradually heating up, but that's another story. So if energy in equals energy out, how can we possibly be using any energy to do anything? What matters, it turns out, isn't simply energy, it's useful energy. And energy is useful when it comes packaged in a low entropy form. The total amount of energy in any closed system can't change, of course. Energy is conserved. But that energy can be in different states of usefulness. There's useful energy in the water behind a dam, which will flow until the level is the same on both sides, but will never go back up. Or in hot tea, which will melt a cold ice cube until they reach a medium temperature. You never see tepid tea spontaneously generate an ice cube while heating up, even though the total energy would be the same. So useful energy is low entropy, out of equilibrium energy that can be put to work, to turn a turbine or push a piston or melt an ice cube. Useless energy, meanwhile, can't be put to work. It's out there in the form of waste heat or noise or the potential energy of a ball just sitting on the ground. We can't really do anything with it. For example, gasoline and air carry useful low entropy energy. By burning them together, we can accelerate a car, drive for a while, then put on the brakes and stop. The total energy of the world remains constant during the trip, but useful chemical energy is converted into useless high entropy heat and noise. The energy is still there, but we can't reclaim it to power any more cars, as convenient as that would be. And thus it is with the Earth. The Sun sends us energy in a convenient, useful, low entropy form, mainly as photons of visible light. This energy gets absorbed and used and degraded by various processes here on Earth until we radiate it away in a much higher entropy form. Lots of infrared photons. For every visible photon we receive, the Earth radiates about 20 infrared photons out into space. Even though there's a balance of energy in with energy out, the entropy of the energy has gone up 20 times. The Sun, in fact, is only a source of useful energy because it's a hot, bright spot in a cold, dark sky. If the whole sky were the temperature of the Sun, our planet would receive a lot more energy, but the Earth would quickly average out to a state of high entropy equilibrium, with everything at the temperature of the Sun. So things like driving or living would be impossible, not because there's insufficient energy, but because you can't do anything when all the energy has averaged out. In equilibrium, all energy is equally useless. Nothing ever changes, and time's arrow ceases to have any meaning.
Hey, Henry here. Thanks for watching. This is the fourth video in a series about time and entropy made in collaboration with physicist Sean Carroll. The series is supported with funding from Google's Making and Science initiative, which seeks to encourage more young people, and people of all ages, to learn about and fall in love with science and the world around them. And the videos are based off of Sean's book, The Big Picture, on the origins of life, meaning, and the universe itself, which you can find online or in bookstores around the world.